Show that log base 9 2x minus 5 is equal to a half log base 3 2x minus 5, and hence or otherwise solve log base 9 2x minus 5 is equal to log base 3 x minus 4 for x is an element of the real number set. Well, the first thing that we have to notice is that our log's bases are different. We have log base 9 and log base 3. And in order to use our laws of logs, well, law 1 to 4, we have to have our bases to be the same. So in order to make our bases the same, we're going to use law number 5, which is the change of base law, which says that log base ax is equal to log base bx divided by log base ba. So I want to rewrite log base 9 2x minus 5 with a base of 3 so that it matches up with our log on the right hand side of our equal sign. So the first thing I'm going to do is write out my law number 5, which says that log base ax is equal to log base bx divided by log base ba. Then underneath that, I'm going to write out my log that's on the left of my equal sign that I want to change, which is log base 9 2x minus 5. So the a is going to be 9, the x is going to be 2x minus 5, and the b, which represents the new base, is going to be 3 because I wanted to match up with my log base on the right hand side. So the a is going to be 9, and that's going to come into our denominator as the new argument. The x is going to go into the numerator, that's going to be 2x minus 5, so we're going to have 2x minus 5 in the numerator, and the b is going to be 3 because we want a base of 3. So the a is going to be 9, that goes into the denominator as the new argument. The x is going to be 2x minus 5, that goes into the numerator as the new argument, 2x minus 5, and the b becomes 3 because we want a base of 3. So we end up with log base 3, 2x minus 5, divided by log base 3, 9. So log base 3, 9 is going to give us 2, because 3 squared is 9. So we can either stick this into the calculator and get 2, or we can use our scorpion tail method that says 3 to the power of x is going to equal to 9, and 3 to the power of 2 is going to equal to 9. So log base 3, 9 gives us 2. And we still have log base 3, 2x minus 5 as our numerator. Now, anything divided by 2 is also multiplied by a half. So I can just stick a half in front of the log base 3, 2x minus 5, and it means the exact same thing. So that's what I wanted. I wanted to show that log base 9, 2x minus 5 is equal to a half log base 3, 2x minus 5, and that's what I've done. So next I need to solve log base 9 2x minus 5 is equal to log base 3x minus 4. So I'm going to swap the log base 9 2x minus 5 for a half log base 3 2x minus 5 because I worked those out to be the same. So I've got a half log base 3 2x minus 5, so I've swapped this for this. Bring down the equals, and then I still have log base 3 x minus 4 on the right hand side of the equals. Now, I want to get rid of this half on the left hand side before I do anything else. So this is half stuck on to log base 3, and anything stuck together in maths means multiply, and the opposite of multiply is divide. So I'm going to divide the left hand side by a half so that I can cancel that out. But if I divide the left of the equal sign by a half, I must divide the right hand side by a half as well. So I'm going to say log base 3 x minus 4 divided by a half, and dividing anything by a half is the same thing as multiplying by 2. Because the reciprocal of a half is 2. So dividing both sides by a half is the same as multiplying by 2. So I end up with 2 log base 3x minus 4 on the right hand side. And on the left hand side I have log base 3 2x minus 5. All I did was just cancel out that half. So I'm going to use law 3 of my log laws to bring this 2 down as a power. So I use law 3 there. So the q in front now becomes the power of x. So I've still got log base 3 2x minus 5 on the left hand side, and now I have log base 3 x minus 2 squared on the right hand side. So that 2 in front of the log came down as to the power 2. So next thing I want to do is multiply out x minus 4 squared. So x minus 4 squared is going to be x minus 4 multiplied by x minus 4, and that's going to end up giving me x squared minus 8x plus 16. So on the left hand side I've got log base 3 2x minus 5, and on the right hand side I've got log base 3 x squared minus 8x plus 16. Now I can cancel out my log base 3 on either side, so cancel out the logs, bring down the 2x minus 5 on the left of the equal sign, bring down the x squared minus 8x plus 16 on the right of the equal sign. I'm going to bring everything over the same side. Since the x squared is already a positive, I'm going to keep that on the same side, and I'm going to keep the minus 8x and the plus 16 all together as well. So I've got x squared minus 8x plus 16. I'm going to bring the 2x over the other side, it becomes a minus 2x, and the minus 5 over the equal sign, it becomes plus 5. So I've got x squared minus 8x plus 16 minus 2x plus 5 is equal to 0. I'm going to simplify, so I've still just got x squared on its own. Minus 8x minus 2x is minus 10x, and 16 plus 5 is 21. Now I can factorize, and then I can solve. Alternatively, I could have used my quadratic formula or my minus b formula. So I'm going to move it up here, and I'm going to factorize. So I've got x squared minus 10x plus 21. I've got an x squared, so I have an x in front of each bracket. I have a positive sign here, which tells me that these signs are the same. I have a negative, which tells me they're both negative. I have 21 here, and the factors of 21 that will end up giving me 10 are going to be 7 and 3. So 7 multiplied by 3 is 21, and minus 7 minus 3 is minus 10. So my factors are x minus 7, x minus 3. I'm going to equal each of them to 0 and then solve. X minus 7 equals 0, so x is equal to positive 7. X minus 3 equals 0, so x is equal to positive 3. So now I need to check which one of these will work, if either will work or if both will work. So if I sub in x is equal to 7, let's say I sub it in on the right hand side. So log base 3, 7 minus 4, that's going to give me log base 3, 3. So I'm going to have a positive argument, so that will work. Let's try on the left hand side here. Log base 9, 2x minus 5 is going to be log base 9, 2 times 7 minus 5. 2 times 7 is 14. 14 take away 5 is 9. So 9 again is positive, so I'd have a positive argument. So 7 will work. Now I'm going to try x is equal to 3. Well, let's say I start with log base 3x minus 4. If I swap the x for 3, it's going to be 3 minus 4, so it's going to be minus 1. Log base 3 minus 1 cannot be defined. I cannot have a negative argument. So I don't need to go any further. Once I know that it doesn't work with one of my logarithms, I know it just doesn't work at all. So therefore x equals 3 is not a solution. X equals 7 is our only solution.